Okay, in this video, I will show you step by step how to calculate the app statistics. In other words, one-way analysis of variance when we cannot use t-distribution anymore. Well, in which situation we can use the t-distribution? So if I have a two independent sample, I can use the t-distribution. Now, notice that if I add another one, three or more, so if I add another one, I cannot use the t-distribution anymore. So I need to have analysis of variance. So I have to analyze the variance inside and between, within and between. So let's take a look here. What is the question is asking? At 5% significant level, does the data provide sufficient evidence to conclude that a difference exists in mean amount of rain among three different cities? So these are the three different cities: North City, South City, East City. Is there any mean difference between three cities? So, well, null hypothesis always we assume the population mean are equal for all cities. That's the null. Always we have to believe whatever the claim hypothesis, we have to believe that's true. Then alternative hypothesis, we say no, it's not true. So we just go opposite. In this case, it doesn't exist, so it's not equal. So we say population mean 1 is not equal to population mean 2, not equal to population mean 3. So that's the null and alternative hypothesis setup. Now the second one, app statistics. So this is the one actually we have to work it out. So app statistics is basically analysis of variance. In other words, between the variance between the sample divided by variance within the sample, between, this is a between, what is the variance between this one and this one and this one and this one, and within, of course, this one plus this one plus this one, this is within. So that is, even though it looks easy, but it is a little bit complicated. Okay, so I'm going to take my time to show you step by step to construct a F distribution or F statistics in this case. Then of course critical value, then we have p-value, then decision and conclusion. So that's how we actually construct hypothesis test. So let's take a look. Let's continue how to find the F statistics. We need a source actually. So let's take a look. We can go down there. Okay. So this is the source we need actually, source of variation. So between the treatment. So while we can say between without a treatment, I can say just between, that's fine. Also, or within, I can say within. So what is within actually, or between? This is very important to understand here. So within this one, these three cities, that's between them. So I'm going to actually have this one here. So this one, this one, this one. So this within, sorry, that's between. So that's a between. Now within is going to be this one plus that one plus that one. In other words, this is within. So whatever I'm getting from here, that would be my within. So this whole thing, whatever calculation comes up, this is within, inside. This is inside. So we're going to add those actually calculations. So I'm going to show you. So that's basically within, and of course within we're going to find the error, and between is basically the total. In this case comes up. I will show you step by step. Now, so let's erase this. Now let's go with the understanding of this. So the between, we said NSE, what is happening in between. So we're going to actually work on those actually between. So SS, that is very straightforward formula. SS. So SS is sum of x square minus sum of x to the power 2 over n. This is on the third chapter or fourth chapter, or almost every statistics book, we learn how to find the variance and how to find the SS. So variance is S square is equal to SS over degree of the freedom. We're going to use the same concept like that, but it's going to be a little bit in range, a little bit smart way, a little bit challenging. Okay, so let's take a look here. We're going to use this concept technically. So SS is sum squared. So sum squared is basically, this is the formula. This is called computation formula. There is a defining formula, and that is more complicated. I don't want to use that. Actually, I personally don't like that defining formula. I like computing formula. So SSTR, what does it mean? SS is sum squared, TR means treatment, or you can say SSB, SSB, another word between, sum squared between, or you can say sum squared treatment. I put down treatment, put down, so I'm just making sure that you can do also like this. You can say instead of this, SSB, if you assume this is your B. And also you want to say SS, instead of SSE, you can say SSW. That is fine. So SSTR, which is the treatment, or if you don't want to use treatment, you use B. So SS sum squared B, or between sum squared and within sum squared, and total sum squared. That's a total sum squared. Okay, so this is a K is the category and -1. So we have 1, 2, 3 category, north, south, east, 3 categories. So 3 minus 1, that is going to be easy to actually calculate. So 3 minus 1 is 2. So that is degree of freedom is 2. And I go down here, MSTR. Another word you can put down, MS mean squared. Mean squared is basically, you can put down, excuse me, mean square between you can have, or you can say mean square treatment is equal to what? Is equal to SS between, sum square between, or sum square treatment, or treatment sum square. It's just coming from there. So we need to find this one in order to find mean square treatment. And also we need to find the error, or within, in order to find the mean square error. And then finally we divide those two and we get the variance between. This is the variance between actually mean square treatment. This mean square treatment is going to be the variance in between, and mean square error is going to be variance within. So once we have that, so let's take a look here. I'm going to keep it as like it. So I'm going to keep it treatment. And also notice that I can find the degree of freedom. I'm going to show you step by step when I go down there. Okay, so first thing we do, step 1 is we can find SST. Another word, total sum squared. In order to find the total sum squared, notice that I need sum square, sum of x square, I need n, I need sum of x. So let's jump into here, original problem here. So original problem here. So I have my n. Well, I can actually add this up here. So I can add this up. If I add this up, it's going to give me 32. If I add this up, it's going to give me 62. If I add this up, it's going to give me 50. Remember, we need those in order to find within. Okay? And also, that would be my sum of x. So what is my sum of x? My sum of x in this case, because we don't have only one group, we have a 3 group, we add all those 3. 32 plus 62 plus 50 is equal to 144. And also I need sum of x square. I need sum of x square. So means I'm going to square each number, 9 square plus 6 square plus 9 square plus 8 square plus 15 square and so on, plus 13 square plus 9 square. That would give me my sum of x square. So that would be basically, I'm just doing, so 9 square plus 6 square. Of course, I don't want to write all of them. I'm going to write down 13 square plus 9 square. That would give me 1598. And also n. So what is the n? I need the n also. N is the sample size. So 5, 10, 14. So that's 14 actually. So I can say 4 plus 5 plus 5, which is 14. Very nice. So I have this. Now, if you don't want to do this calculation like that, you can use a calculator actually. So that will help you. Well, in any calculator actually. So I would love to use this calculator. So I'm going to actually type it in here. So I'm going to say 9. Of course, I have to type it in the data. So data is clean. If it is not clean, you erase it. So 9, enter. 6, enter. 9, enter. 8, enter. 15, enter. 12, enter. 11, enter. 13, enter. 11, enter. 11, enter. 13, enter. 4, enter. 13, enter. 9, enter. If you know, you can skip this little beacon. Okay, so I need to get the second data, enter. I'm finding everything total, so I just use one variable and calculate. Now I'm looking for sum of x and sum of x square. You can get this through the calculator also. Look at this here. Sum of x is 144. Exactly same thing, we have 144. And sum of x square is 1598. So you don't want to do this, it's fine. You can actually use that calculator also. So calculation is good. Okay. Now, the step 1 is going to be finding the SS. So that is going to be step 1 actually, I would say. Step 1. So step 1 is SST. SST is equal to sum of x square minus sum of x to the power 2 over n. In other words, we are looking for total sum squared. So if I type in all these, 1598 minus 144 square over 14. My SST is going to give me 116 point. I did a little bit ahead of time. 186. So approximately that. Again, how did I get all this? Look at here. That is 144 and that is 1598 and n is there. So as you see, just plug it in. Okay, so let's erase this mess here. Step 1. Now step 2, so I have my SST. In other words, I have my total sum squared. Then I can go with the treatment sum square. Once I get the treatment sum square, I can subtract actually, then I can get the error, or in this case is within. So if I have a total, if I can somehow calculate the total and calculate in between, then I can get the within. I subtract it, then I can get the within or error. So let's do the SSTR. That one is a little bit complicated, most probably. Okay, so SSTR is going to be SS, let's do this here, SSTR. What does it mean again? This is a treatment sum squared or between sum squared. So SSTR is equal to, we have a formula. We're going to keep the similar formula. This piece is going to be similar, but it seems like we are going to find, we are now looking for total, or in this case, sorry, not total, treatment. We're doing the treatment here. So treatment in between actually. So we have to actually work out this one, everything here. Whatever the sum, we divide by n. So this is something we have to look into. Okay, summation over n, and of course divide by n. We add all of them. That will be sum of x square. Okay, so that is, so let's write down the formula here. So sum of total in this case, well, I would put down total, TOTAL, total square over n. Remember, that is very important. This is the little bit complicated steps. Sum of x to the power 2 over n. Okay. So as we see, we have total square. So what is the total? Look at this. This one is under the north groove. Is total square is this one. So 32 is the total. So that is going to be 32 is the total. under north group. And this one is the total is that, and total is that. So what I'm going to do is basically I'm going to square them. So I can actually go move a little bit this side. So I'm going to say 32 square over 4 plus 62 square over 5. In other words, I'm getting this 32 square, I'm going to square it, over 4, sample size, 62 square over 5 plus 50 square over 5 minus sum of x, which is 144. So 144 over n is in this case 14, and of course 144 is a square. Okay, so I did ahead of time and I found that is 43.66. So what is that? This is SSTR. Or let me actually write something a little bit this way. So my SSTR is equal to 43.66. So that is my SSTR, sorry about that, not RT, SSTR, and that is my SST. We need both of them, it's very important. And so as I go through, right, I can actually plug it in. So for example, oh, by the way, again, 32 square over 4, that's the sample size, and 62 over 5, and so on. You square it and you get that. As we go through, we can just fill it in actually. So this is 116.86. So this one is 116.86. Also, we found the treatment sum square or between sum square, 43.66. As we go, we can just plug it in. Now notice that we need the difference here. So SSE, now we go with the SSE. So what is SSE? So step 3 is SSE. SSE, in other words, within the sum squared. So what is that SSE? The difference between total, so SST, total sum squared, minus treatment sum square. So we already have the total, which is 116.86 minus 43.66. So that would give us SSE, in other words, error or within is going to give us 73.20. 73.20. So that's another one we found. So the little bit calculation I would like to share with you here. So this one, how do you do? So that is basically you put down 32 square n over d, 4, go to the right side, plus 62 square n over d, over 5, go to the right side, plus 50 square n over d, 5, go to scroll to the right, minus 144 square n over d, and of course 14, enter. Look at that, it's 43.66. 43.66 exactly is matching here very nicely. So 43.66. Excellent. Now this one is easy to handle actually. So we have pretty much everything here. So I'm going to actually, so 73 point. So as I see, I have 73 point SSE, that is my SSE, 73.20, 73.20, right on top here, 73.20. And SST is coming from the very first one here. SST is coming from very first one here. Okay, and also this one here. Okay, so these are the calculations step by step. So this is what we actually need. Okay, so I don't need this information anymore actually. So you can always go back and check it out. So I'm going to erase it, or I don't have to erase it actually. Here you go. So the next thing what I do, I actually go down here, this one here. So I know this is my treatment sum squared, this is my error sum squared, this is my total sum squared. So the degree of freedom, so let's take a look here. I am going to actually erase this side here. Okay, and I would see k is the categories of group 1, 2, 3 groups. So k minus 3 minus 1 is 2. Excellent. Then next one is n. N is what? Total sample size. Sample size means we have how many number here. So n we already have 14. In other words, 5, 10, 14. So 14 minus 3. So it's going to be 14 minus 3. 14 minus 3, it should be 11. So that is the 11 as we see. 11. Or I can just write down 11, right? Or right there, I can write down 11. 11. Good. So let me make it a little bit bigger here. Okay. Alright, so I have 11. Now n minus 1 in this case is 14 minus 1, which is 13. So again, n minus 14, total sample is 14, so 13. So we have a degree of freedom. Now I'm going to divide this. 43.6 is divided by 2. 43.66 divided by 2, I would get 21. So actually I can use my calculator, or you can use a calculator. So that would give me that this one is going to give me 21.83. That is 43.6 is divided by 2, 21.83. And then 73.20 divided by 11, it should give me 6.65. So this is going to be 6.65. Okay, so we don't need this anymore actually. Look at this. We use this one to get within. So now we have these two. We just basically divide those two. So my F distribution is going to be, we just basically, let's arrow down to the top here. So we're going to do actually 21.83 divided by 6.65, and that would give us 3.28. 3.28. So that is our F statistics. Now, if you go down here, as you see, we have everything step by step. So let's take, we have everything: treatment sum squared, or between sum squared, within sum squared, and of course total sum squared. We found one extra thing, total sum squared, in order to find the within sum squared. So we subtract this one from that one, we get 73.20. Now degree of freedom is 2. K is the 3 categories. 3, 1, 2, 3 category. 3 minus 1 is 2. And n's total sample size, which is 5, 10, 14, or you just add this up individually. So it's 14 minus k, which is 3, is 11. And again, n is 14 minus 1 is 13. So this is degree of the numerator, and this is degree of the denominator. My apology. This is degree of the numerator. That's actually go up here with this one. And this is degree of the denominator. So we need those concepts in order to find the critical value from F statistics. So we divide this 2, we get 21.83. We divide this 2, we get 6.65. And of course, we divide variance between divided by variance within. So if you divide, our F statistics come out to be 3.28. So that's the takeaway here. So now we're going to go with the hypothesis test. So this is the test. Let's take a look here. We go down. That says at 5% significant level, does data provide sufficient evidence to conclude the difference exists in mean amount of rain among 3 different cities. So first I said, whatever is the claim, we just have to assume they are equal. So we say mean 1 or mean A is equal to, null hypothesis equal to mean 1 equal to mean 2 equal to mean 3. Or I can say A, B, C. We assume they are equal. The next thing we do, they are not going to be equal. They are going to be not equal actually. Next one is going to be not equal. So, or at least one mean is not equal. At least one mean is not equal. Okay. Now we do the AP statistics. So we already did so much crazy stuff as you have seen. AP statistics come out to be 3.28. 3.28. And the critical value, so this is for critical value, we have some stuff to work out with this. So there is, that's how we actually use read the critical value stuff, okay? Is good for all the table. So if it is F distribution, you go alpha is equal to 0.05. Remember, F distribution for each significant level, there is a different table. So technical reason, I'm not actually pulling out that, but if you are working on ANOVA, you have your F statistics, F table. So, and of course, this is going to be degree of the numerator, and this is degree of freedom of denominator. Okay, so we already know that was 2 and that was 11. So we go down here and we come along with the F critical value, in this case 3.98 from the distribution. So our critical value is 3.982. Now, once I have p value, well, p value is the best we use. Actually, I'm going to come up with the p value later on. Let's actually come up. So first, in hypothesis test, we assume they're equal. Right away, we say they're not equal. So in order to trust who is right, we have to do the test. So we investigate what is happening between them. We analyze the variance. So we did analyze the variance. We found 3.28 is the test. Now the critical value turned out to be 3.982. So well, if I use the AP statistics, that is AP statistics here, AP statistics. So the critical value, I would say this is 3. Okay, so that one I'm going to go maybe. Okay, 3.982. So my critical region is going to be this to the right side. Critical region is to the right side. So, but I did the investigation. So the right side of the critical region is basically, right side of the critical value is the critical region. And on the left side is not critical region, it's a safer zone. It is housing. Okay, so anything fall on the left side, it's going to be, you fail to reject. You don't reject, you keep it. Anything fall, and what is anything? Anything means the test. You did investigate the test. You did all the calculation. The test come out to be 3.28. So 3.28 most probably is going to be here somewhere. 3.28 is somewhere here. 3.28. So guess what? Our test conclude that we fail to reject the null hypothesis. In other words, whatever is the claim, we actually go with that. So we fail to reject. So that's how we write it here. Fail to reject. Fail to reject. What? The null hypothesis. Fail to reject the null hypothesis. Now, in order to find the phi value, we actually use the technology. That's the best thing actually. Use the technology, otherwise it's a little complicated. So I just use the technology and I found my phi value is 0.076. So with that also,